And as a result, I can stop it. So you can see that this explosion is very weak. It's not going from the guided geometry. It's still blue color. You can see the explosion. The moment it's bam, but there is no such a big power or the force which will add transition from the guided geometry to the RBD. So what we can do, there is a few moments we can change here. Let it stop. Let's canceling this. Let's back to first frame. So the first thing I want to do, I can change the strength of the explosion. Come on. Canceling. Okay, this guy's geometry. All right, so here what we can do else, well, end frame is 100. It doesn't matter, but anyway. Okay. Go inside of the RBDs. Also, I change, come on, the strength here. You can see the strength multiplier is depending on the distance. The bigger distance, the less strength. By default, it's 0.3 here. I changed to 0. So if we have a distance more than 5, it will have a 0 strength. I don't need to guide objects in such distance. Okay, so let's change to manual again. Go down inside and let's change the strength to 100. Something like this. I think that it should be enough. Maybe we will increase it like 125. Let's do like this. And what I want to do else, I can go here to my points from bottom, and let's change the point separation. Let's switch to update. Go to frame 25. I want to increase a little bit more points here, so it's point separation 0.75. It will increase amount of points. And because of the volume rasterize attributes, it creates like a spheres around those points. And well, the voxels and voxel size 0.1. Let's maybe increase like 0.2, something like that, a little bit bigger. And what we can do else, so let's see at the result in this moment, because we change the strength of our explosion. And let me just check what we can do else here. The outputting attributes I will enable in the last moment, because I don't need to import for now nothing. Let's increase the number of sub-steps to like 9 by 9. In the final result, I can increase it to 10 by 10. Okay, so collision padding, linear threshold, I'm gonna leave those guys as it is. All right, so back again, and let's look at this simulation with new settings. And we can see a difference. We definitely can see a difference. So now this explosion is much better. Bam. Some part is flying away. Some elements. All right. So let's wait till all other explosions will be here. I want to look at the moment with the second explosion, how many elements we will break. I want to take the part of the ship of the side. I want that the explosion go not just from the top, from the deck and from the side of the ship. I want to have this explosion, like a part of have some kind of bending, because it's like a metal. And what else I want to do? I want to create explosion near this gun. Maybe the part of the gun should fall down, and it's will look nice. Some elements you can see fly away, and you can see though that our constraints are working here. You can see that we have a fragment, the big fragment in this area, in here and here, and it creates some kind of deforming for the metal, and it's looking good. Okay, so it's take a time. You can see that it's already 40 minutes take calculation to frame 40. It's not too fast, and the reason is because we have a lot of geometry. Also, we have a nice upstepping. There's a lot of elements, and you should calculate it. And definitely where we add a little bit more elements, even more elements, and when I add the small object, the other group, which we remove at this moment using the blast node, so we will add it on the final seam, and it's gonna take more time, even more time to calculate. So as you can see, I'm not using the old cache from my last simulation, from my last project. All what we create in this training, all we did from scratch. And yes, it will be a little bit different because I have a little bit different settings, a little bit different setups, so it can be a little bit different. But the main task of tutorial of our training is to show you the methods we can use for creating some kind of this simulation. All right, so I stop it for the moment and wait till the next explosion. I want to look how it's looking. I want to see how it's looking. And this is the second explosion, and it's a little bit bigger than I expect. You can see the ship is moving. We are guided objects. You can see that this is still guided. It's still blue, so it means that we drive by the animated object. And the second explosion is pretty big, and the reason why it's big because we have a few explosions in one area, one frame by one, and we have a huge amount of fragments. Maybe in some cases it should be good, but I like how the bending here, it's nice, like a metal structure, but I don't like such a big amount of well, it's very fast moving. You can see that those huge part of the ship will fly away with a high speed, and it won't looks too realistic. So what I want to do, I want to change the strength of the explosion. So we can go by a few ways. The most simple way is we can go inside of the RBD sim and change and animate the strength. Come on. So it's 100 by now. Okay, I understand. It's 100 by now, so we can animate it like in frame 25. It's going to be 125, and in a frame like 46, 49, when we have a second explosion, it will be a little bit weaker. But also, what we can do is we can use like a global multiplier. We can set that, okay, maybe different explosions will have a different strength. And how we can do, in fact, is pretty easy. We can take our velocity, like after the attribute randomize somewhere here, and multiply this velocity by some float value. Multiply it to set a strength of our initial velocities. So how we can do this? We can go back. We have our explosion spheres. Let's go to those. Here we go. So this is our explosion. Okay, and each point here is our explosion in frame 25, frame 46, 47, 49, and so on and so forth. What else I want to do? I want to look at my ship. So let's go back to geometry. I want to look at the ship. So the ship import, let's enable. I don't want to look at guns, or yes, I want to look at my guns also. So yeah, let's enable. Let's turn on the guns and my explosion animation. Let's look at the points here. So 25 is one explosion, and we have 46. Here's another one, and it's close to the to this gun, pretty close. And he has the last explosion good, which actually this last explosion will break the side of the ship. But what I want to do, I want to make this explosion more close to the gun. So I want to create explosion near this gun. So I want to move this element from the explosion. So let's just drag this position a little bit upper, so it will push the gun up. And let's tweak, let's add another attribute, and let's call this the, the explo scale. And for the fast explosion, let's set it 1 and 25. And what I want to do, I can go back to my dynamic here, set the manual. Sorry, manual. I don't need to import nothing here at this moment. Go to manual, and oops, where you are. Okay, and let's set 100. So it's like 100, and I can multiply velocities using the explosion scale attribute. So that should be 1.25. Let's copy this. Let's go to the next explosion, and this explosion is near the gun. Okay, so we can tweak it. We can play with this and with this. So I'm going to copy this attribute, and we can change the scale for each of those explosions. So the last explosion, I think it should be a little bit weaker because it's great, nice bending, but it's sending the metal fragments far away from the center of an explosion. And this explosion should be much weaker again. So let's 0.35 like this. Oops, sorry. And let's say 1 for this. Okay, so the fast explosion will be, well, the strength will be 1.25. This should be 100. This will be like 35 scale and 85. So, and we transfer this attribute through the explo animation. It's going here to our dynamic setup. And somewhere over here, before we go into the volume rasterize attribute, what I can do, I can take my points and go to auto update. Let's go to frame 25. It's cooking something, I know what. Let's stop it for a moment. Let's enable the attribute wrangle. Go to frame 25, and let's go to jump to spreadsheet. So do we have any, where is my attribute? I guess I'm not transferring this. So the explo scale is here, point from volume, and we lose our attribute. So point from volumes. I need to transfer the attribute from my points here. So we can simply just take our explo scale attribute and attribute transfer. So take this, and all the points. I want to transfer my, need to change inputs. I want to transfer my explo scale. So now all points here have the same explo scale. Cool. Right here the attribute wrangle, and we can type the explo scale. Exactly what I want to do is multiply my velocity by the explo scale. I can set it's a float value. Alright, so in this case, if we turn on and off this, you can see the velocity became bigger. On frame 46, here you can see that it doesn't change nothing because on frame 46 we have the x plus scale, as you can see, 1. So attribute delete. Now when I use this attribute, I can simply delete him from this. I don't need any more nothing here, and I convert this convert the points into the volumes. All right, so now I will have a different scale for my explosions. Now, before I go ahead, I want to remove the blast node at the moment. So now I will use create simulation for all my objects, even for the other group. So as you remember, we take our other group with the small elements and we remove it using the guided group. So our main geometry have included in guided group. So when I remove the blast, it means that now we will have the full geometry. Let me just show you this. All my fragments from the ship, all what we have on the ship, but those small elements from the other group, they don't have a guided group. So inside of the guided group, we have just the main fragments, main elements from the ship, the hull, guns, all other things. And what does it mean? It means that if we use the guided simulation, if we use this guided simulation, all what we put inside of the guided is just main fragments. The small object will not be included in this. So if we try to explain. So our main elements is our ship. There's some elements on a ship, the guns. All the thing is inside of the blue group, which is guided. And all small elements, okay, on the surface somewhere here on the ship, they connected with the constraints to our main geometry. Okay, and those constraints are pretty strong. So if we take our fragments from the guided group, okay, and create an explosions, those fragments will fly away from the ship. All those tiny small elements will fly with the fragments because they connected with constraints. If you have a big explosion, big strength, big force, they can be breaked and fly away because we have settings for the for breaking constraints into the guided geometry. So that's our main structure for the sim. And what else? I want to cache this simulation, just to look at the simulation closely. It not even with increasing the memory cache to 10,000 megabytes, it takes just a few frames stored because there is a lot of information, a lot of geometry, and we can cache just a few frames. So to better representation of all those explosions and how all this works, I want to cache this simulation and look closely on each frame separately. So I want to save this scene. And for the saving, we have a few options. We have 4 outputs. So the first 3 outputs is pretty understandable. It's main geometry, constraints, and the proxy geometry. In our case, as you know, the proxy and the main geometry is the same kind of geometry because we're not using our main fragments from here. What we want to do, we need to take our proxy geometry and then apply those proxy geometry for deforming our main fragments. So what we can do in this moment, we can take the force input, and the force input is, I don't know what's happened, something wrong in the background, and the force input is the simulation points. So again, let's move back to manual mode. Sorry, I want to allow editing of content and show you another way. Come on. Allow editing of content. So yeah, let me close this. And from the DOP import, as I said, yes, we take the points to represent object and then merge those points with the geometry. And that's what we have for the first input. Well, we take those points and scale some points to same points. So with this output, which is here output number 3, and this means that it is output 4 because 0, 1, 2. So the input 1 is the simple geometry, which drive it by the points. The input 2 is simply our constraints. Here we go, output 1, out constraints. The output 3 is the same points, but we use transfer from pieces, not from the main geometry, but from the proxy geometry. And the fourth input is simply we take those points and just going out. So what I want to do, I want to take those points and store them to the file cache, match current definition. So if you go here and let's set a null object, I want to connect this null to points. You can call this sim points and look at those points. To do this, I can go to frame 23, I guess, when we begin our simulation and update this info. It's take a while, so I make a pause and we're going to look at those points, how they're represented, and what is more important to understand what attributes they have. So how we can use those points later. And now you can see it's take like 3 or 4 minutes for updating, and it's just without any simulation, without any explosion, just putting geometry inside of the RBD sim, create all those guided elements, and then back them back as the points. And if we look at our attributes we have, it seems like all's fine. We have a velocity, angular velocity, but it's by 0 now because there is no explosion again. The scale, the pivot, orient, so all those attributes we need to have if you want to put geometry on those point positions. Also, we have a name, but as you remember from our test dynamic, the name, the correct name is very important. And in this case, if we want to use those points to drive our main fragments, what we should have is have the same names, because how program can say that, okay, I want to use those points for creating deforming of this element, okay? So it's not just about position. So if you have like a main fragment here, okay? And as you remember, we divide and separate this fragment into the smaller frags. And now we use those smaller fragments to create the RBD simulation. And as a final result, we take each point from this fragment and store and cache this. But now if I want to say, okay, let's take this huge fragment and use those points to make a deformation for this fragment, we need to know that this point is should apply to this fragment. So it's using the name attribute. So all those points and this fragment should have the same name. And as you remember, we store this name into the old name attribute. It's a small piece, so they don't have an old name. We doesn't create a structure, but all elements with the main frags, with the GAN frags, they all have the old name. All elements we created to level fragmentation, they all have the old name attribute. But our points from the simulation doesn't have the old name. They have just a name attribute, and it's separate name for each of those pieces. But we can't link it because those names of the small pieces is not the same like a name of the big fragment. But if we take the info from the first input, let's create another null object and go to connect it to geometry. Now we're gonna have a geometry. I hope we can visualize this without any recalculation. because I don't want to spend again like 5 minutes to look at that. Yeah, so now we have our fragments, and inside of those fragments we have the old name attribute, which is very important. So it's not a sim points, sim geo. So now what I want to do, I want to use the attribute copy node. I want to take my points and copy the old name attribute to this point. So I set the match by name, and I want to transfer, the first thing is my constraint type, and I will show later why I want to copy this, and also I want to copy the old name. The constraint type I want to save because I want to separate my elements. I want to take my main fragments, just points from the main fragments, and apply those to the geometry. Okay? Because we're not creating deformation from other group. So the other group is just a simple geometry, and we don't need to create a deformation based on those. I just want to select my main frags. So that's why I want to use the constraint type. Constraint type. I select metal and say, okay, now all my metal elements I want to deform. All other elements, like static elements, they will be like rigid bodies without any deformation. So now I want to store this info. So I use the file cache. And another one important thing, that if we save just the points, it will use less disk space because it doesn't create geometry just using those points, okay? And then we apply those points to existing geometry. So we can, some kind of optimization. All right, so let's rename it. I don't know how to call it, bullet sim. And I can say version 01, just in case we'll create a few of those. Go to frame range, that's correct, beginning from the frame 33. Load from disk, and I need to use a heap name. So $F, saving to geometry, let it be there. Okay, from 23 to 100, that's what I want to do. Now I'm gonna save this project and create a simulation, and we will see what do we have there.